Hello and welcome. My name is Doreen Schäfer and I will moderate this session today. The topic of this webinar is Demystifying Bluetooth with Würth Elektronik Solutions based on nRF54. Next to me is my colleague Balzs Markus. Hello.
Hello.
Nice to meet you. Who is an embedded software engineer for our product area wireless connectivity and sensors. Bluetooth connects our world from headphones to smart homes. But what challenges arise when designing Bluetooth solutions? Let's explore the essential. The stage is yours.
Thank you very much.
You're welcome.
All right, so today we are going to talk about Bluetooth. Generally the evolution of Bluetooth technology, fundamentals and architecture of Bluetooth Low Energy. We are going to take a look at a couple of practical applications and use cases, and we are also going to take a look at a novel chip, nRF54 by Nordic Semiconductor, and Würth Elektronik's Proteus-IV, a solution based on this radio chip. So let's begin with some fundamentals of Bluetooth technology. What is Bluetooth actually? Well, Bluetooth is simply put a way for devices to talk to each other wirelessly. The idea came from a desire to replace cables between mobile phones, PCs, wireless headphones and wired headphones. Bluetooth operates in the 2.4 GHz radio band, which is called the ISM radio band. It's an abbreviation for industrial, scientific and medical. It's a globally available range that is free to use. Now, if you want to officially call your product Bluetooth and you want to use the Bluetooth logo, you do have to register your product. It means listing with the Bluetooth SIG, and you also have to pay a listing fee. The Bluetooth SIG is the special interest group. It's an organization that defines and maintains the Bluetooth standard. It includes over 35,000 member companies, including giants like Ericsson, IBM, Intel, Nokia, and Toshiba as well. Every major version, like Bluetooth 4.0 or 5.0, is basically like a huge PDF file that is being uploaded to the website of SIG, and every chip manufacturer can implement their own version of it. So let's just take a look at the evolution of Bluetooth technology. Bluetooth began in 1998 with version 1.0, and it was called Bluetooth Classic. Early work focused on basics like pairing, speed, and security. But then in 2010, Bluetooth 4.0 changed everything with Bluetooth Low Energy, or BLE. And this technology was built for the rise of small battery-powered IoT devices like sensors and fitness trackers. Since then, nearly all development has shifted to BLE. Classic Bluetooth remained there, but it's mainly just maintained, and it's there for backward compatibility. The Bluetooth SIG defines each version in the core specification, as I mentioned, which is basically like the blueprint. Let's just talk about the key differences between Bluetooth Classic and Bluetooth Low Energy. So what's the actual difference? Bluetooth Classic is what you usually use for streaming audio from headphones or speakers. It's built for continuous data, meaning that the radio stays on all the time. It's great for high bandwidth, but it consumes quite a lot of energy. Bluetooth Low Energy, on the other side, works the opposite way. It sends short bursts of data. We are going to take a look at that later. But after that, it turns the radio off and it saves actually power. But here's one catch. Bluetooth Classic and Bluetooth Low Energy are not compatible. They share the same 2.4 GHz band, but they are just simply using different protocols, so they are talking different languages. So at the beginning of your project, you actually have to decide which technology to use, but we are going to talk about it later. So as I mentioned, what makes Bluetooth Low Energy? As you can see on this graph, at the top, Bluetooth Classic communicates continuously, and it always sends data. As you can see, the master is transmitting, then slave 1 is transmitting, and then slave 2 is transmitting. It never shuts off. That consumes quite a lot of power because the radio always has to be on. On the other side, if you take a look at the bottom, Bluetooth Low Energy actually has some sleep intervals in between. And this is defined by a connection interval that can be anywhere between 7.5 milliseconds to 4 seconds. So short bursts of data are being sent, and after that, the device goes to sleep. So Bluetooth Low Energy is good for data that is kind of bursty in nature, like, for example, temperature readings and some control signals, where you don't have to send continuous data. You just want to, for example, turn a light on or off or read the temperature. Let's now talk about some core concepts in Bluetooth Low Energy, which are the roles, how a device can act. Two main roles are officially known. There are a couple of other roles as well, but let's talk about the two main ones. A peripheral is like a slave in a master-slave relationship. It has data or services to offer. Think of it like a fitness tracker or a temperature sensor or a smart bulb. These devices advertise themselves. They're just saying, hey, I'm here, you can connect to me, and then they are waiting for a connection. They are usually simple and low power. A central, on the other side, is a master. For peripherals, decides who to connect to, and it manages the connection as well. Your smartphone or gateway device collecting sensor data is usually a central device. So your smartphone, obviously a lot of people usually know Bluetooth from smartphone connections, and your smartphone is usually a central. But I have to mention smartphones can actually act as both central and peripheral devices. BLE also defines broadcaster and observer roles, by the way, but they are not that relevant in this sense, what we are talking about today. So let's now talk about how actually Bluetooth low energy devices work and find each other. This is called the advertising and scanning process. On the peripheral side, the device broadcasts what we call advertising packets. These go out on three specific channels. We call them the primary advertisement channels. You can see them with yellow on this graph on the screen. Let's talk about these channels. BLE operates, as I mentioned, in the 2.4 GHz ISM band, which is a globally available frequency range. Industrial, scientific, medical use, but by the way, even microwave ovens are using this frequency channel, just as like Wi-Fi, VLAN, as some of our viewers know it. So this band is actually officially divided into 40 channels. And each channel is 2 MHz wide. Out of these, 3 channels are used for advertising, and 37 of them are used for data communication. Now, imagine the spectrum as a pie with 40 slices. Each slice represents one BLE channel. And the whole pie is the 2.4 GHz frequency band, and the channels are numbered from 0 to 39, as you can see on the screen. The 3 advertising channels are channels 33, 38, and 39, marked with yellow. Bluetooth uses these advertising channels, as I mentioned, to tell the other devices, hey, I'm here and you can connect to me. And all the other channels are used for data communication, but some of these channels actually are overlapping with Wi-Fi channels. Bluetooth actually uses some physical technology protocols defined in the link layer called frequency hopping to avoid interference with Wi-Fi channels. And the advertisement channels were also placed in a way to maximize spectral separation, meaning that hopefully, and thanks to these algorithms, your connection is going to be successful and quite reliable. So why only 3 advertising channels? Well, as I said, to minimize interference with Wi-Fi. The peripheral can actually also control how often it advertises. You can go really fast, like every 20 milliseconds, or you can even slow it down to save battery, like maybe even once every 10 seconds. Obviously, if you advertise faster, you're also using up more battery, but this is basically a trade-off that you have to decide on. There are different types of advertising packets too. Some are connectable. They are saying, hey, you can connect to me. But some of are not accepting connections. For example, like beacons. They are specifically there to just advertise their presence, but they are not accepting connections. They are good for example, indoor localization, but they are not there for data transfer. So yes, here's the thing. If you need fast discovery, you actually advertise frequently and scan aggressively. But if you want to save power, you can decide to not scan that aggressively and not advertise that aggressively. So, as I said, the advertisement packets contain useful information, not just about the connection type itself, but also about different parameters. For example, if you are in a Bluetooth low-energy audio application, it can advertise the codecs that are being used in the audio application, or actually the fact that the device supports LE audio. So, once the central finds a peripheral it actually wants to talk to, let's look at what actually happens. So first the peripheral is sitting there advertising and it's minding its own business. And then the central, as I said, the master scans and discovers it. And then the central sends a connection request, basically saying, I want to connect with you. And the peripheral responds with, OK, I accept that. And boom, the connection is established. At this point, both devices switch from those advertising channels that were marked with yellow in the previous graph to data channels that were marked with blue in the previous graphs. And then now they start talking to each other in those remaining 37 channels. But there are some important parameters that control how this connection works. The connection interval is probably the most important one. We could actually see that connection interval before in the graph where I explained the difference between low energy and classic. This connection interval defines how fast the two devices can exchange data. It can be anywhere from 7.5 milliseconds to 4 seconds. Obviously, a larger connection interval means that you will be able to exchange data not that often, but on the other side, you are going to be able to save more power, which is very useful for devices that do not require frequent data communication, but they can actually operate on a single battery cell for a really long time, even months. One more thing, and this is very important for system design, a central can actually connect to multiple peripherals at the same time, and the peripheral can have connections to multiple central as well. This is a key feature of Bluetooth Low Energy. So let's look at how data is actually organized in Bluetooth Low Energy using the generic attribute profile. A characteristic is a single piece of information, like a temperature reading, battery level, or a switch state, like on or off. Each characteristic has some properties. Can you read it? Can you write to it? Or can you even get notified when it changes? Every characteristic has a so-called UUID, some standardized like battery level and some custom for your application. Characteristics are grouped into services, which are logical connections of related characteristics. For example, an environmental service, which is defined in the Bluetooth standard, might include temperature, humidity, and pressure. Some services, like the battery service, allows devices to communicate about the battery state. Or there are also custom services. For example, with Würth Elektronik, we also designed some custom services that enable efficient data communication between a couple of our modules. We are going to talk about our modules later. But first, let's just take a look how we got here. Right now, actually, we are at Bluetooth version 6.1, which was just released this year in May. Actually, Bluetooth Low Energy was released with Bluetooth version 4.0, as I mentioned before in the evolution history. And after that, a couple of different versions were released, like 4.2, which improved privacy, allowed larger data packets. Then came 5.0 in 2016. It was a major leap because the speed was almost doubled, and an important feature was released, which was the coded physical layer, which enabled long-range communication. You know, Bluetooth Low Energy always had this disadvantage of short range, and the Bluetooth SIG tried to address this problem by introducing the coded physical layer, which introduced a trade-off because you have to decrease your throughput, but with this decreased throughput, you can actually increase the range between your communicating devices. And in 2024, Bluetooth 6.0 arrived, and a very important feature was introduced called channel sounding. This enables centimeter level distance measurement between two Bluetooth devices. And as I mentioned, as of now, 2025, the newest version is Bluetooth 6.1, which just arrived with some energy optimization, some enhancements, chip-based address randomization, and the Bluetooth Special Interest Group actually decided to move on to a twice-yearly update cadence from this version. So let's just take a couple of examples. What can Bluetooth Low Energy use for? Obviously, I mentioned a couple of them before. Fitness trackers, consumers, and wearables are a major category. But in smart homes, you can also always find some kind of a Bluetooth Low Energy module or chip. Not that many people know about it, but in industry, actually, Bluetooth Low Energy is getting large traction nowadays. Because BLE enables with dimensions like indoor positioning, asset tracking, and predictive maintenance. It is definitely a useful technology for industrial applications as well. And another major area is retail, where BLE beacons like iBeacon or Eddystone power in-store navigation, notifications, and they can even help contactless payments as well. Across all these examples, the reason is the same. Bluetooth Low Energy gives reliable wireless communication with ultra-low power and just the right data rate. Not too much and not too little. So that's why it's everywhere today. Let's just talk about what challenges do we face when we are designing a Bluetooth Low Energy device, because designing with BLE isn't always easy. Here are the main challenges that I myself, as a Bluetooth Low Energy developer, have already faced. First, and I guess this is the most important, is power optimization. Balancing quick response with long battery life takes careful tuning. As I mentioned, connection intervals, data rates, throughputs, all those parameters require fine-tuning, because if you just set one parameter right, your battery life might be majorly affected. The second one is coexistence. As I mentioned, and you could see on the graph as well, BLE shares the 2.4 GHz band with Wi-Fi devices and Zigbee devices and many other wireless technologies. And devices must handle interference without dropping connections. The third one is range versus throughput. Long range means usually lower speed. High speed shortens range. So you need to have to pick the right physical layer, as I mentioned before, for your application. The fourth one, this is also a major thing, especially nowadays, is security. BLE security is generally strong, but only if implemented correctly. Pairing, encryption keys, secure boot, and protection against attacks all require expertise. And the fifth one is RF design and certification. So antennas must be optimized. Regulatory approvals like FCC, CE, or IC take a lot of time and also money. So using a module instead of a standalone chip solves many of these challenges for you, saving effort and risk. Let's just take a look at the nRF54 series from Nordic Semiconductor, which is a core of Würth Elektronik's newest solution. The nRF54 L15 is Nordic Semiconductor's latest ultra-low power multi-protocol system on a chip. It supports Bluetooth Low Energy, but besides of Bluetooth Low Energy, Thread, Zigbee, and Matter, and it can even switch between them at runtime. At its heart, there is a 128 MHz ARM Cortex-M33 processor with 1.5 MB of flash and 256 KB of RAM. It is plenty for advanced embedded applications. It also includes many features like a global RTC for timed wake-ups and a 14-bit analog-digital converter, and high-speed serial interfaces. This is all built in. But where it really stands out is security, because there is a cryptographic accelerator with side-channel leakage protection and also secure boot included. And it also includes ARM Trust Zone technology, which is a novel security feature for applications that really require enhanced security. So before we talked about challenges, and let's just talk about how nRF54 tackles these challenges. So for power, it actually achieves sub 1 microamp current. I could actually measure a little less with some specific applications. For coexistence, there is smart frequency hopping implemented in this chip. For the range throughput trade-off, actually all Bluetooth physical layers are supported, 1 megabit per second, 2 megabit per second, and the coded physical layers as well. For security, I mentioned a couple of features already: hardware-based root of trust, trust zone architecture, and the cryptographic accelerators, enabling you to implement really secure applications with this chip. And about the RF design, Nordic provides many reference design, and Würth Elektronik's pre-certified modules take care of the antennas and the certifications, saving you months of work. So let's just take a look at the Würth Elektronik's approach to wireless connectivity. Our vision is simple. We want to make wireless integration as easy as possible for engineers. We know that not every company has RF experts on staff, so not everyone has the time to design their own solution based on a standalone chip like the Nordic Semiconductor one that I just showed before. And on the other hand, there is another challenge, that your solutions have to be certified separately if you are deciding to use a standalone chip instead of a module. That's why we provide some pre-certified modules. FCC, CE, IC, every certification is already done. And the firmware itself is also ready to use that handles all the BLE complexity. We provide comprehensive development support, we provide evaluation boards, we even provide an SDK that you can use with the most common microcontroller development boards to get you on track as fast as possible and get your solution running as fast as possible. Our Bluetooth portfolio has two main lines. The Proteus series, which is a ready-to-use module with pre-installed firmware. You have to turn it on, then send a couple of commands via some interface, usually UART or SPI, and all the other BLE connectivity stuff is handled for you by the module. Bluetooth usually supports all BLE roles, and it is also designed for fast integration. On the other hand, we have the so-called Ophelia modules, which are similar to Proteus modules, but they are fully customizable. And it's basically a flexible development platform which doesn't include a pre-installed firmware. We can also help you with custom firmware development, but you are also feel free to use your own development environment. The most common one is obviously nRF Connect SDK if you are working with Nordic Semiconductor chips, and Zephyr RTOS is one of the recommended solutions for this environment. Obviously Bluetooth LE, but other technologies, as I mentioned before, can be also integrated depending on your project needs. So the development ecosystem is complete. Hardware, as I mentioned, we provide eval boards, breakout boards, reference design, everything. For software, we provide software examples, we provide SDK, software development kits, and also some configuration tools that you can use on your PC, on your smartphone. So this is the complete package that makes Würth Elektronik different. We are not just selling you a chip or a module, we are selling you a complete solution, and we are there from the beginning until the end of your project. Besides of our products, obviously we have a couple of other modules, Wi-Fi, Matter, or wireless M-Bus, for example. But on today's presentations, obviously, we are focusing on Bluetooth. And I'm very happy to introduce you Proteus-IV, which is our next generation Bluetooth low energy module. At the heart of it is the already presented Nordic nRF54L15 that we were already talking about. The CPU is a Cortex M33 running at 128 MHz, and the module itself is really compact. Its size is 12 by 8 millimeters. It supports Bluetooth Low Energy 6.0, and it is already ready for Bluetooth Low Energy 6.1. As I mentioned, based on the fact that it's based on this Nordic specific chipset, it is already equipped for all kinds of future technologies, and regular updates and maintenance are to be expected from us. The output power can actually go up to 8 dBm when you need maximum range, and the power consumption is actually excellent. When transmitting, it consumes around 10 milliamps, but when it's going to sleep mode, I'm actually managed to measure definitely below 1 milliamp or 1 microamps, 0.6 microamps even. So with the deep sleep, you are going to be able to build an IoT solution that can run on batteries for definitely months, maybe even more than a year. So other features, and a very critical feature, obviously, it is pre-certified. CE, FCC, IC, and of course the Bluetooth listing itself is already done. This alone can save you 6 months or tens of thousands of euros in your product development. This is a great module, and it's designed for professional product development, and it actually has the features, the certifications to back it up. So let's just quickly talk about the Proteus-IV operating modes. It has a transparent mode, where you just basically turn the module on, and you are immediately going to be able to connect to the module with your smartphone. And we actually provide an app called the Bluetooth Low Energy Terminal that you can use to just send some messages to the module, like for example in a chat, and the module is actually going to be transmitting those messages to its serial interface. But if you want more customization, command mode is also available, both peripheral and central. In this mode, you can send some specific commands to the module and customize many of these features. If you want security and recoverability, we provide a config mode where the module always operates at 9600 baud, 8M1, no flow control. So you don't have to be worried that, for example, if you change the baud rate on your serial interface, you are going to lose communication. You are always going to be able to recover your device. And obviously, according to the latest trends and security requirements, we support firmware over-the-air update. That's why we implemented photo mode, where you can wirelessly update your firmware via BLE. We provide all tools and necessary frameworks for future updates as well. So every security feature that you want to maybe implement in the future is going to be updatable using Würth Elektronik's provided tools. So let's just talk about flexibility and customization options and what you can actually do with Proteus-IV, because this is where it really gets really interesting. With the standard firmware, as I mentioned, you get a rich command set that covers all common BLE operations. But here's the thing, obviously standard firmware can't cover everything because everyone might have custom needs. So that's why, as I mentioned before, with Ophelia-IV, we are also going to provide you a custom solution that you can use to develop your own firmware. For example, maybe in the future you want to be able to implement some channel sounding measurement, or you want to have some specific communication standard implemented. You are going to be able to do it if you are using our modules. Basically, all features of the nRF54 L15 are going to be available. Besides of that, as I mentioned, we provide plenty of development support to these chips, those SDKs that I talked about, the STM32 examples. But besides of that, we also have a couple of application notes where we describe step by step, like just in a tutorial, how you can implement your solution as easy, as fast, and as cost-effective as possible with Würth Elektronik modules. And if you would still have some problems, our expert technical support team is always there for you. You can always ask us questions, and we are happy to answer, because as I mentioned, we are there with your project from the beginning until the end. So our recommendation, when you are designing a project with our Bluetooth modules, you can simply start with a simple application with the standard firmware, and maybe if you recognize that you want to have some custom implementation or custom technology implemented, you can always switch to custom firmware variants. Let's just compare quickly Proteus-IV with our previous Bluetooth Low Energy module, Proteus-III. As you can see, the Bluetooth version has been updated by a lot. Our latest modules supported Proteus-III supported Bluetooth 5.1, and the Proteus-IV supports Bluetooth 6.0 with all the upcoming features. And as I mentioned before, it is already ready for 6.1. With the sleep current, we actually managed to improve as well. With Proteus, it was guaranteed under 1 microamps. With Proteus-IV, I just measured it a couple of days ago, and the module actually was able to reach under 0.6 microamps of current. That is actually a serious improvement in power consumption, meaning that your IoT application is going to be able to operate on batteries even longer. The chipset was updated from nRF52 to nRF54, as I talked about, and on security features, it also brought major enhancements. And of course, as this is a new and oncoming product, compared to Proteus-III, Proteus-IV has a long-term future, and we are also going to always re-evaluate all security updates and all kinds of new feature improvement. Proteus-III is also going to be there, obviously, for long-term customers, but for new designs, we definitely recommend using Proteus-IV. So currently, Würth Elektronik Bluetooth module portfolio has 2 Bluetooth modules, Proteus-E and Proteus-IV. Proteus-E is an older one using the Bluetooth 5.1 standard. It is still available, and it will work with most Bluetooth applications. But its main feature is actually the small size of it, because its footprint only has 7.7 times 9 millimeters, which makes it even smaller than Proteus-IV. And it actually has lower cost as well, but it has a reduced feature set compared to Proteus-IV. So our recommendation, if you ask me, new design has to be started with Proteus-IV. So just quickly about which development support we give you. I mentioned it before, not just on the hardware, but also on the software side, documentation and support as well, what we provide. We provide datasheets, we provide an online technical support team. You can always call us or write us, and we are going to answer you. Doesn't matter if it's a hardware-related question or a software-related question, we are also always going to be there for you, because support is a key element of our company. So just to wrap it up, why Würth Elektronik is a right choice for your Bluetooth low energy needs. Pre-certified modules get you to market faster, saving months and significant costs. We use Nordic's nRF54 series, which supports Bluetooth 6.0. This is the latest technology and it is future-proof. We have flexible firmware, a complete ecosystem. Our support teams are experts and are always there for you, as I mentioned. Our pricing is pretty cost-effective, and we have a long-term commitment, so you are not going to be left alone after 1 or 2 years after a product has been released. If you order a module, you can be sure that in the long future, we are always going to be there for you, and we are going to support you with your application, or if you have some problems, we are going to be able to provide support to you. So that concludes my presentation about Bluetooth Low Energy and our newest Proteus-IV module. Thank you very much first for watching my presentation and listening to my presentation. Right now, I'm very happy to accept questions regarding the presentation and the modules itself. Or generally, if you have questions about Bluetooth Low Energy, I'm there to answer it.
Perfect. Thank you very much. Balzs, should we switch? Perfect. Just going to switch them. All right. So thank you very much for your presentation. The chat was quite active, so we have numerous questions. Yes. So let's sort them. Maybe we start with the first one. So what does it mean in detail, twice yearly update cadence?
Exactly. That means that Bluetooth SIG has made a commitment that every major Bluetooth version release is going to happen every 2 years. As you could see on that history chart before, Bluetooth releases happened quite infrequently before. For example, last versions were released in 2024, now in 2025 we already have a new version. That makes us think, okay, should we release a new module? Should we release an old module? And obviously other manufacturers are also thinking about, like, should we release a module that supports a higher version of Bluetooth? This makes the entire process more predictable and calculable.
Thank you very much.
Yes.
Great answer. So let's see what's next. I think Matthias was referring to slide 15, update of which BT standard, Bluetooth standard, firmware update, rate required, or what?
I'm not really sure which slide was that about, but I'm just trying to answer this question. So the Bluetooth standard, let's take a look at the Bluetooth standard. Most of the technologies, so for example, if a Bluetooth module is based on 5.1, for example, like Proteus is such a module, it doesn't actually automatically mean that that module is obsolete or you can't use it anymore. You can still be able to use it. But for long-term designs, I would definitely recommend using a version that has the highest version number, because usually that will mean that it will be supported by most devices. What defines support? Obviously, for example, if you have a smartphone, that will probably support the newest Bluetooth Low Energy. If a new smartphone is going to support the newest Bluetooth Low Energy technology. But it is going to be supported for many years. About the firmware update, well, as I mentioned with Proteus, we already have firmware update over the air implemented. So in case there is an update need in the future, you are going to be able to do that. But from the factory, the modules are going to be having the higher security level that is currently possible by the Nordic chip. All right.
Perfect. Regarding to this one with the Nordic chip, I have another question from Helmut. Do you use Nordic chips only or also other chipset manufacturers for Bluetooth?
We are in partnership with other companies as well, not just Nordic Semiconductors. For example, on one of our other modules, SoC1 uses, which is a Bluetooth classic and low energy combo chip, uses a chipset by Infineon. And that chip is also active. It was recently released. It is mainly targeted at Bluetooth classic applications. But as I mentioned, Infineon is also a partner of us. But our main Bluetooth solution, Proteus-IV, relies on Nordic Semiconductor solutions.
Well, good to know. Thank you. All right. So I skipped a few questions. So let's talk about Herbert's question. Are there early samples already available from the nRF54 chipset?
So from the chipset itself, I would say yes. If you are partnering with Nordic Semiconductor, you were already able to get that chip. But if your question is targeted at the Würth Elektronik Proteus-IV module, our earliest deliveries will happen at Q1 2026. But I would definitely recommend you to get in touch with us, maybe write an email to us, and if we can take a look at your solution, and maybe we can let you know as soon as we can ship you a Proteus-IV module, then we are going to get in contact with you, and you are going to get some evaluation samples.
And that's good advice. You can send us an email anytime. All right. Thank you very much. So let's have a look. There's another question from Matthias. Maybe we can have a look at that. Is there free space or the possibility for own code in the SPP-like version of the Würth module? Example, to read values of the ADC and send it using the SPP profile?
Yes. So just to put it clear for all the other viewers that don't know what SPP-like means. SPP was the serial port profile that was traditionally used with Bluetooth Classic to send serial port-like data and create a virtual COM port on a PC using a Bluetooth module. Bluetooth Low Energy doesn't have such a feature, but we can emulate this function by having a custom service, a custom characteristic, which we call the Würth Elektronik SPP-like service. So basically, you can still plug your evaluation board to your computer, connect it with your smartphone, send some messages. So from the practical point of view, you won't be seeing any differences. If you mean custom code, that your custom application wants to read some data and transmit it via the SPP-like profile, I would definitely recommend you to use a host controller with the Proteus-IV chip, because our firmware is locked on the module. Your other option would be to use the custom firmware variant, but obviously then the entire SPP-like communication has to be implemented there as well. So what I would do in your case, get a Proteus-IV module and just use some cheap microcontroller to read out the temperature sensor data and transmit that data via the transparent UART or SPI interface of the Proteus chip.
Perfect, thank you. So I think we have still a lot of questions left. So let's have a look. Oh, this one is from Herbert. Do you have any design-in support on your side?
Yes, we have an expert hardware team that is happy to answer you any kind of designing question. Just feel free to write a message to us or write an email to us. We can actually take a look at your application and give you some insights. We have many expert hardware developers. By the way, I am a software engineer myself, but as a hobby at home, I also like to develop wireless circuits, radio circuits. So you can also personally message myself and I can give you a couple of insights. But obviously, I'm just a software engineer. We have expert hardware engineers as well that can provide expert support to your needs and with the designing.
I see, we have a true expert with you here. That's great. So let's move on. Okay, this question is from Arnulf. Does the HCI interface still exist?
Yes, so HCI is there as an intermediate layer between lower layers of the Bluetooth stack and upper layer. Yes, it actually still exists. Generally, with, for example, our other module, SoC1, we were using HCI for testing different features, and you can even control the module with it. HCI is a very technical and not that easy to use interface for most of the users. That's why obviously our preferred method of using modules is not using the HCI protocol or HCI interface, but rather using our well-defined UART interface with those pre-specified commands. So the short answer, yes, it still exists. Long answer, you already heard. It's a very complicated thing, so I would only recommend it for expert testing and maybe certification purposes.
Thank you very much. That was detailed information. So we still have a few minutes left, so I would say we can answer some more questions,
of course,
right?
Yes.
Perfect. So this one is from Ferdinand. Can firmware be updated in field? Which interfaces are supported for updates?
Yes, of course. As I mentioned before, the firmware can be updated in field as well. There is a mobile app for that, and everything is going to be described in the user manual. I myself have prepared a tutorial for it, which is going to be released in the Proteus-IV user manual. You can use a mobile app for it to upload it to your Proteus-IV module. Which interface is used? Obviously, the app itself, and to be more technical, it uses the SMP protocol of the Bluetooth module to send the firmware over to the module, and it uses a dual bank partitioning on the inside memory of the chip. So, for example, if there would be some error during firmware over the air update, you are still on the safe side, and your old firmware is going to be able to be recovered. So this is a well-defined and well-implemented update mechanism that we have on the Proteus-IV module.
Wow, that sounds like we did something very great here. All right. I'm not sure if you already answered that one, but maybe we can just do it again. The SPP
sure.
was already. Do you have modules with SPP or not? So data communication over UART interface.
Yes, we have. As I mentioned, we have, let's talk about pure SPP, which was in Bluetooth Classic. For that, we have the SCOL1 module. Just feel free to go to our website. It's already there, and you can see all the user manuals and details and examples. So it supports the Bluetooth Classic SPP profile. But if you just want to send serial data and you don't really care about how it's done under the hood, I definitely recommend you to take a look at our Proteus-IV module, because as I mentioned, it can do the same with lower energy consumption and still achieving the same result. The decision is yours, so you can use classic SPP or SPP-like as well. So for SPP, I recommend to take a look at SCOL1, which is our Infineon-chip-based module, and for SPP-like, you can take a look at Proteus modules with Bluetooth Low Energy.
Perfect, thank you very much. So many answers. Okay, let's see. Hui, this sounds like an interesting one for Matthias. Can I turn the Ophelia module into a Proteus-like module just by uploading firmware or using libs?
Yeah,
from
firmware
Würth?
or using libraries.
Yes.
So the short answer is yes, of course. With that, we can also provide you some support. There is a specific user manual and application notes for the Ophelia modules as well. And we can support you with implementing all the features that you need in the Ophelia chip. Feel free to reach out to us, and we can provide you all the development tools that you need with it. Basically, it's very similar to developing for any kind of Nordic Semiconductor chip. So there is nothing new about developing a firmware for our Würth Elektronik chips. But yeah, as I mentioned, feel free to reach out to us, and I myself am happy to help with that topic.
Perfect, thank you. Balzs, you're going to have a lot of work after this webinar. So the next question from Andreas. What are the main advantages of this solution compared to a solution with an ESP32C3 apart from power consumption?
Consumption, yeah,
Consumption.
Exactly. Well, personally, I was using ESP32C3. Probably the person who asked the question have already met our Stefano 1 module, which is our solution based on ESP32C3. The main advantage of this, I would say, definitely relies in the firmware. Our ESP32-based solution is a module that is, while cost-effective, I wouldn't really call it as easy to use as our Proteus module. With the Proteus module, you can definitely achieve your target, I would say, a lot faster if you only want to have Bluetooth communication. You already mentioned the power consumptions, which is obviously also a point. I'm not going to talk about that, but obviously that is our main feature because it's a Bluetooth low energy module, and that is specifically built for low energy consumption. And obviously all the newest features that only the Nordic Semiconductor chip provides. So I think that was a great question.
It was. Thank you very much for answering it. Sadly, time is up now, but don't worry, we will answer all of your questions afterwards. Balzs will get in contact with you and send you the answers via email.
Definitely.
Yes, we also uploaded you the link to our Digital E-Days website. Please feel free to enter other seminars, and hopefully we see you soon again. Have a good evening.
Have a good evening.
Afternoon.